Now the second success criteria we're going to look at is determining the equation of a perpendicular line if we've got the required information or appropriate information. So we've got this line here, y equals 6x minus 5, and we're looking at the point 1 and 1. So we want to find the equation to a line that is perpendicular to this at this point. So what we'll do is we look at our equation. Well, we know that the gradient m is 6. So then the gradient of the tangent, not y. So the gradient of the normal, or the line perpendicular, is 1 over the gradient. Well, and it's negative 1 over that. So then therefore we're going to have y equals negative 1 over 6x plus c. Oh well, how do we find c? Well, we substitute these values into x and into y. So we'll say 1 equals negative 1 over 6 times 1 plus c. So we've got 1 equals negative 1 over 6 plus c. So we bring this 1 over 6 across to the left-hand side, and it becomes 1 over 6 plus 1 equals c, and then this ends up becoming 7 over 6 equals c. So that's what we're left with. So then from there we'd say the equation is y equals negative 1 over 6 plus 7 over 6. So that's the way we go through it. If you are given it in the form of ax plus by equals c, well then we rewrite it in terms of y. So then this will become by equals c minus ax, and we divide by b to make y equals c over b minus a over bx. And then here we have our gradient, that's our m, so it'll end up being, and we find the reciprocal of that, and the reciprocal of this, so the negative reciprocal of that is positive b over a. So that's the steps that we'd need to take for there. So to recap, got our equation, we've got our point, we find the negative reciprocal of this, of our gradient, and we substitute our point into, and we rewrite that, in y equals mx plus c, and then we substitute that into that form. If we're given this, if we're given it in another form, well then we go through the same steps, or we rewrite, we don't go through the same steps, we rewrite in terms of y equals mx plus c, so we've got a coefficient of x, and that we have as our gradient.